Welcome to The Explainer. Today, we're going to demystify the magic behind modern AI, and we're doing it by looking at a massive, fundamental shift in how computers actually operate. We're breaking down the exact difference between those decades-old, rule-based programming systems and the totally revolutionary way machines are learning to navigate our world today. So, if you've ever found yourself wondering how artificial intelligence really works behind the screen, well, it all starts right here. Let's dive into rules versus learning. Okay, picture this. 47,382 plus 91,655. You punch that into a standard $5 desktop calculator, and boom, it immediately tells you the answer is 139,037. It executes this incredibly complex calculation instantly, and it does it perfectly. Every single time. It never gets tired, it doesn't make typos, and it never gets distracted. It's just flawless execution. But watch what happens when that flawless execution completely hits a brick wall. If you show that exact same calculator a slightly blurry photo of a cat and ask, "Hey, is this a cat?" What happens? Error. It has absolutely no idea what to do. It literally cannot process the image. It's completely blind to something that, honestly, a human toddler could identify in a fraction of a second from across the room. So why is that? Why on earth can this machine perform insanely complex mathematics perfectly, but completely and utterly fail to see a simple cat? This isn't just some weird quirk of cheap electronics, guys. It's the fundamental mystery of traditional computing. Understanding how these baseline machines operate gives us the answer to this riddle, and it really sets the stage for the entire modern AI revolution. All right, Section 1, the old way, fixed rules. To really grasp this AI revolution, we gotta look back at the foundation of computer science. I mean, this is the paradigm that built the early internet and literally put humans on the moon. Under the traditional rule-based system, a human programmer has to anticipate every possible universe of scenarios in advance. You have to write these exact, uncompromising commands telling the computer precisely what to do. That calculator? It only knows the rigid mathematical rules someone explicitly burned into its chip. It can't learn a single new thing on its own. Think about the everyday traffic light. It's a classic, everywhere you look, rule-based system. The logic is super predictable. If 30 seconds have passed, then switch the light from green to yellow. And look, for really structured tasks, this if this, then that logic works brilliantly. But think about how absurdly rigid it is. If it's 3 a.m., absolutely no one is at the intersection, and a huge traffic jam is building up in the opposite direction, the rule doesn't care. It can't adapt. It just blindly clicks away on its timer. Moving on to Section 2, the limits of rules. So rigid rules are fantastic for adding numbers or cycling traffic lights. But man, they completely shatter when forced to deal with the messy, unpredictable nuances of real human life. Imagine being some frustrated programmer back in the late 90s, desperately trying to write rules for an early spam filter. Like, what does a bad email even look like? You tell the computer, okay, if the email contains the word lottery, mark it as spam. Or if the sender is unknown, mark as spam. You're basically trying to plug holes in a sinking ship using static logic. Because, the real world adapts. By the early 2000s, a staggering amount of all internet traffic was pure spam. The spammers immediately realized you blocked the word lottery, so they just spelled it with a 0 instead of an O. And what does the rule-based system do? It lets the junk right through, because it doesn't match the exact instruction. So you have to go back in and write another rule, and another. Soon you're maintaining millions of rules, updating them every single day, and still failing miserably because the rules are just too brittle for such a dynamic problem. Which brings us to Section 3, the machine learning flip. Okay, so this total exhaustion with the rule-based method, it led computer scientists to just completely invert the entire programming model. Instead of handing the machine answers in the form of rigid rules, they built a way for the machine to find the rules itself. And here's how that crazy architectural flip actually works. Step 1. Instead of writing explicit instructions, you feed the system thousands, maybe even millions of examples. Think of emails already labeled by humans as spam or not spam. Step 2. The system studies those examples. And Step 3, and honestly, this is the real game changer, the system builds its own internal rules based on what it just observed. Now, during that study phase, the machine is basically hunting for patterns. And a pattern is simply a recurring structure or regularity that you can detect in data. The machine isn't actually reading the email to understand the psychology of the scammer, right? It's mathematically analyzing word combinations, formatting quirks, how often a specific sender operates, or even hidden code in the header. It finds these super subtle statistical regularities that link all the spam examples together. And by doing that, it completely bypasses the need for a human to ever write a single instruction.
And hey, this shift is the exact reason your email inbox is actually usable today. If you look back at those early 2000s filters that relied on rigid keyword rules, they were so incredibly easy to fool, and our inboxes were a total disaster. Modern filters, though, they use pattern learning. They've ingested millions upon millions of real emails, catching ridiculously subtle patterns that a human wouldn't even dream of writing a rule for. The result is a highly accurate system that is constantly adapting to new threats.
Let's dive into Section 4, Myth versus Reality. You know, when we throw around words like machines learning or studying, it's super easy to get swept up in all the sci-fi hype and start projecting human traits onto software. The big myth of modern AI is that these computers understand language or images conceptually and emotionally, exactly the way you and I do. But the reality? It's just statistical pattern matching in pixels. When a machine correctly identifies that blurry cat photo from our very first example, it doesn't know what a cat is. It doesn't know that cats purr or that they feel soft. It simply recognized mathematical patterns in the arrangement of the pixels that heavily correlate with the label cat. So, while the output mimics human understanding, the actual mechanism behind it is just advanced statistics, not genuine comprehension. So to close things out today, I want to leave you with a question to really ponder. What task in your own daily life would be absolutely impossible to write exact step-by-step rules for, but is incredibly easy to learn just by seeing enough examples? Like, just try to think about writing a mathematical rule for recognizing your best friend's face in a huge crowd, or knowing exactly when a joke is funny. You can't do it. The real world is wildly messy, and rigid rules break down incredibly fast. But by flipping the script, by moving from giving strict instructions to providing examples, we've finally taught machines how to navigate all that beautiful mess. Thanks so much for diving into this with me today on The Explainer.